So, hi student, welcome once again to another video. Today we are looking into elasticity, simple machine and gravitational fields. For those that are just joining us for the first time, this is the Mosaic Academy UTME and Waec 2022 exam prep. And all we do is to make sure we take you into the questions and how to solve them accurately. And we also make sure we explain the concept by providing a concept video for each and every topic. For this will also help you, particularly for those who are ready for questions and who are ready to tackle questions with respect to the exams they want to do. So what we do is just to solve 10 questions with respect to the topic. So if you are just joining us, you can actually go through all the one we've done for the first 3 days, check them, and as well, if you have any problem with any of the solution, you can actually write a mail to me, or feel free to drop a comment in the comment box. And most importantly, don't forget to subscribe and like the channel. So we'll start with the work of today. The first question is, as the extension in an elastic string is increased from 100 to 180 Newton, the string is extended by 10 centimeters. The work done in increasing the tension in the string is dash. Now, we're focusing on the concept of elasticity here. And from the concept of elasticity, we might have studied that work done on force is equals to the force multiplied by the extension. I'll call the extension for now displacement. So directly, we can say the force has moved from 100 to 180. That means the net force is like saying 180 minus 100. So this goes without saying this is 80 Newton from what we had. So if we go by that, the extension is 10 centimeter. You and I know that you have to convert that to meter. So, and if you go by the way you do it, 10 divided by 100 is 0.1 meter. So if we go by the multiplication, we can say 80 times 0.1, and directly the work done, increasing the force. I am not calculating the work done to extend the string. So please note that. So 80 times 0.1 is going to give me 8 joules, and that is the right answer to this question. So the first question of today, as you can see, is 8 joules. And I think that is a very popular concept we might have learned in our junior classes. Now, the next one says a force F applied to an elastic string of length L. Apologies for my voice. I'm having a very bad voice. I hope it's time it will change. And a cross-sectional area A results in an extension X. If E is the Young's modulus of the string, then dash will hold. I think in my concept video class, we have already done this. But for the concept of elasticity, there is a property we call modulo of elasticity. And under that, we talk about Young modulus, which is popular in junior classes. In junior classes, it is given directly by your teachers as Young modulus, which is noted by E, is the stress, the tensile stress, because there are different types of stress and say strain, divided by the tensile strain. So the stress divided by the strain. So also in junior classes, the concept we need to know here is just that stress. When you stress a wire, tensile stress is the force over the area, whereby the strain is the extension over the length. The extension here, if I don't make mistake, was X. The length was L. Extension over the length. On simplification, we can write that the Young modulus is now equals to force over area divided by extension over length. By cross multiplication, because all options actually made F subject of the formula. If you are a beginner, you can write F A first, is equals to EX over L. Then if you also cross multiply again, like I said, we've done this time and time again, force is equals to, you have what they call EAX divided by L. So this will be the correct answer. And this is the formula we use to calculate the force of an elastic string in terms of the Young modulus. Like I said, Young modulus is not the only type of modulo of elasticity that we have. We have others like the Bock modulus and so on and so forth. And another thing is called compressibility of wire. So all these are the new method. Like I said, you are going to be tested with the new method, but it is always good to actually know the basic concept. And these are the basic concepts I believe you need to learn. So we move to the third question. And about the third question, we are still on the concept of elasticity, like I can see here. A spring of natural length extends to a new length under a tensile force. If Hooke's law applies, the work done in stretching the string, you can see this is under the concept of work energy theorem, which we have discussed also in day 3. So the concept of work energy theorem is also applicable in your words. This is for system of bodies. When you have system of body, work has been converted to energy. So far work has been converted to energy. Look at this. The energy now, the work, that is a force that is applied to the body, has been converted to the energy. So now, guys, so that means the work done is the same thing as energy used in stretching a wire or the string. So energy is always given as half KE squared or half Fn. Always keep that in mind. But there is a condition here. There is a condition. It was stretched from its natural length, we call that L, to a new length, according to the interpretation, that is small l. So that's what? The energy is half multiplied by the force, multiplied by the change in the length. So the change in length from the illustration, from the options, we have half multiplied by the force. Then the change in L is from the what? The new length to what? The old, I think the new length was capital L and the old length here was small l, according to the option. So it is now capital L minus small. So this is the interpretation we give to what? The work done in stretching a wire or stretching a string. It falls under the work energy theorem and also under the what? Application of what? Work energy theorem under the topic of elasticity. I hope students get this, and I hope there is no confusion whatsoever with respect to the first question. So the next one, I think the correct option today is choice C. The next one, a machine having a velocity ratio, I think we are now in the concept of simple machine, requires a weight of 20 kg to overcome a weight of 60 kg. Fine. The efficiency of the machine is that. As you all can see, I think these 3 topics, why we take them together, is that they are very simple and direct, but nothing is simple if you don't have the idea. But that is why we are taking you through the process. Like I said, you can see questions with applications actually cross into each other. So about the efficiency of a simple machine, in your junior classes, you might have studied that efficiency is always the mechanical advantage of a machine divided by the velocity ratio of a machine. You multiply this by 100. So if you go through that, in this question, I think the velocity ratio was given directly, and that is 4. But you need to understand what we call the force ratio, also called mechanical advantage. It is a dimensionless quantity because it's a ratio of force. So it is always the load divided by the effort. So the load here, as you can see, is the weight, the load, and the effort is what you put to push the weight. So look at this, require a weight of 20 kg to overcome a 60 kg. So the load is 60 kg weight over effort that was applied was 20. So if I'm not mistaken, we have 20 divided, 60 divided by 20, which is 3. is the mechanical advantage. So directly, you can go with your junior classes formula, which says MA VR4 multiplied by 100. 3/4 of 100 is 75%. And I think this is direct. Another thing you can always keep in mind for your simple machine is that the efficiency of a simple machine is always less than 100 because of what? Some of the work is done to overcome friction. I hope you have studied this in junior classes, and if not, you can always what? Listen to my voice when I take you through solution. I'm just going to mention some other things you need to know. The efficiency of a machine is always also the work output divided by the work input multiplied by 100. So these are simple formulas and illustration you need to keep at the back of your mind to be able to what? Have your full marks in the forthcoming examination. So we move to the next question, which is question 5. According to question 5, we have another type of machine, which is called a wheel and axle. It is under the classifications of machine. In early classes, classification of machines are 6. One of them is the wheel and axle. Then in this question, we are told a wheel and axle is used to raise a weight of 720 with an effort of 200. Just now, we talked about the concept of force ratio, which is called mechanical advantage. And that is load 720 over effort 200. You can say 2 year 36, 2 year 10. That is 36 over 10. That is 3.6. It is a dimensionless quantity. It has no SI unit. So we continue. The radius or the radii of the wheel and the axle is 40 and 10 respectively. So the efficiency of the machine is dash. Just now we said efficiency of a machine is a mechanical advantage over the velocity ratio multiplied by 100. Now, doing this, we can say, how do we get the velocity ratio of a wheel and axle? It is always the radius of the wheel. I hope you have studied this, divided by the radius of the axle. You can keep it in mind. It's also very important. Radius of the wheel divided by radius of the axle. And doing that, the wheel has a radius of 40. The axle has a radius of 10. 40 by 10 is 4. So directly, we can now substitute to get the efficiency, which is 3.6 divided by 4 times 100. On simplification, 4 can go 100 25 times. So 3.6 multiplied by 25 is going to give you nothing but 90%. So that is how to solve this type of question that falls under the other classification of machine that is called the wheel and the axle. So choice D is correct for this. We are going to move to the next question. About the next question, we have a body of mass 20 kg is pushed up a smooth plane. A smooth plane means there is no friction. Incline at a 30 angle of 30 degrees to the horizontal. Absolutely popular question. The force needed to push the body up the plane. This is also under classification of machine, and another special type of machine we classify to be an inclined plane. Now, basically, it is not even more like an inclined plane because this is more like direct knowledge of your friction that we have studied on smooth plane and resolving friction or forces into 2 dimensions. Now, the force acting on the body to push it up, that is the tension. Tension moving up the plane is always given as mg sine theta. I think I've talked about this under the concept of friction. Mg sine theta. You can draw, but I don't think this is needed here because G is always 10. You might have studied that in your junior classes. The mass here is 20 multiplied by G, which is 10, and the sine of the angle sine 30. Now, from here, I think you can say T is equals to 20 tens at 200. Sine 30 is 0.5, but you write it as half. 200 times 0.5 or times half is 100 Newton, which is a question for the tension needed to push this thing up the plane. And this has been talked about in the concept of friction. Now, again, for the machine classification of an inclined plane, let it be known that the velocity ratio of an inclined plane, the simple in junior classes, is the reciprocal of the reciprocal of sine theta, which is 1 over sine theta. So you can also keep that in mind for future questions, provided we were able to see the new pattern that asked about this, we are still going to let you know. So the next question, which is question 7, I guess, says, I think we are now on the concept of gravitation, the little concept of gravitational field. If the force of gravity on an object of mass m, the gravitational field strength is G. The gravitational field strength G is given with the following equation. Now, be careful in some question during your examination that there will be a typographical error. You can actually try as much as try to get there. For example, gravitational force under gravity is given as F over m. It is called the gravitational field strength. You know, this one is called force of gravity. Remember, you know that weight equals to mg. Taken. If you make G sub the formula, you say the weight divided by the m. I'm using small m, excuse me, divided by the m. So the weight is the force, the gravitational force divided by the mass. So this is the relationship we give to it in what? Gravitational field. So the gravitational field strength is called gravity. Keep that at the back of your mind. So it's the ratio of the force by a unit mass of the planet. So always keep that at the back of your mind. So you can see all these options are not written well. This is wrong, this is wrong, this is wrong. This is G equals to F over M. So be careful about questions like that. They are not typed well. You will know if you know what you are doing. That is what I always test for. So this is the right answer to the question. The next one is question 8. 2 more to go after this. The force with which an object is attracted to the earth. I think this is a bonus question, but if you don't know it, you should know that every object is attracted to the earth by the force of gravity. When an object is thrown up, it will definitely come down. So please, I think this is a cheap question. Gravitational force is one that is pulling all objects back, or pushing all objects back, or pulling them rather to the earth or to any planet. So, but it is the earth. We are told that when you want to to the moon, there is no gravity. We know that. Now, the next question, which is the 9th question, last but one, we call it penultimate question. Now, about the penultimate question, we have an object is situated within the Earth's gravitational field. These are still basic questions on gravitational or gravitations. The concept, the other question, I think, will be in the 5, whereby we take some other question with respect to some other topic. We are trying to take all questions on topic 10 per day. Like I said, the penultimate question is object is situated within the Earth's gravitational field. Which of the following factors does not affect acceleration of free fall? I have done this in my concept video before. I told you that if an object is placed on top of on top of a planet and is allowed to rotate, the force which allows the body to move around the planet is called the centripetal force, which is given as mv squared over r, which is the mass of the object. Thereby, the gravitational force that is holding is given as gravitational constant, the mass of the planet, which is always cat, and the mass of the object divided by the r squared. As you can see from here, if you cancel this, we are going to see the mass gets cancelled out. My point is here that whenever an object is situated in a satellite, you can check my satellite motion. As the object is falling or its orbit is moving around, the orbital speed, the free fall, acceleration due to gravity or free fall, does not depend on the mass of the object. As you can see, the mass of the object has cancelled out. One of the r also cancel one of the r here. So you can cross multiply and bring the formula for what we call this is v squared, not v2. You can bring out the formula of your orbital speed. So we say orbital speed is now equals to under root of gmp, mass of planet, over r. So this formula is important, and remember that G is equals to F over M. We just talked about that now. On substitution, you can get all this stuff. It is very, very simple. So now substituting this now, you get the value of what? V equals to root GR, G small letter R. So now, what am I trying to say? You can see the gravitational force here only depends on the orbital speed and the radius. In fact, it is not only the gravitational force. When an object is undergoing a satellite motion, it does not depend on the mass of the object. As simple as that. Always keep that at the back of your mind. If you have any doubt, watch my concept video on gravitation and satellite motion. That is that. And like I do say, my videos are for both beginners and for advanced students. So next question is what we have talked about just now. The force required to make an object of mass m traveling with a velocity v turns in a circle of radius I is that. You can see, we just talked about that. The centripetal force is given as mv squared divided by r. These are things you might have studied in your junior classes or even under circular motion. This needs to have been talked about. So keep that at the back of your mind. These are questions that you see nowadays, and this is how to answer them. And this is where we are going to stop the section for today. If you find anything that interests you, kindly subscribe to the channel and tell your friend about it. This is going to be from A to Z. All topics are going to be treated with details, examples, questions solved, and reason why answers have been picked. I'm going to make sure I take you through them. So see you guys soon. You have a wonderful time, and bye for now.